Hello students, how are you all? Welcome back to Akshar IIT Foundation classes. I am your chemistry faculty S. Mohan. So students, grade 8 IIT Foundation, and in the volume 2 we started the mole concept and stoichiometry chapter, second chapter, and in that we completed this 2 synopsis, and today the third synopsis, that is oxidation number. What it is? Oxidation number, which is also called as oxidation state. It is also called as what? Oxidation state. Now let us see what is meant by the oxidation number. So oxidation number can be defined in different ways, students, here, but in simple way that the number of electron lost or gained by an atom during the chemical bond. That's all. This is simple definition. So many definitions are there. The net amount of charge that to be present on any atom in a molecule is called also oxidation number. So like this many are there, but here we take the simple definition. Very simple. The number of electrons lost or gained by an atom during the formation of chemical bonds. This is simple. Otherwise, we can say that the net amount of charge that to be present on any atom in a molecule, okay, is called as a oxidation number. So you can understand. For example, you see here. For example, here I'll write the definition. Simple definition I'll write here. Oxidation number is the number of electrons lost or gained by any atom, okay, during the chemical bonds, in the formation of chemical bonds. Okay, I'll write chemical bonds. Easy to understand this one. Okay, so this is known as the oxidation state or oxidation number. So what is oxidation number? Oxidation number is the number of electrons lost and gained, lost or gained. Okay, instead of and we can write or gained by any atom during the chemical bonds. Okay. Other definition what we can write? We write other definition like the net amount of charge. The net amount of charge present, okay, in on any atom in a molecule. Like this also we can write. So many definitions are there. So now I'll explain the meaning of this one by one. So here the number of electrons lost, you know that, okay, atom is neutral, right? It consists of, why it is neutral? Because the number of protons present in the nucleus is equal to the number of electrons revolving around the nucleus. Protons are the positively charged particles and electrons are the negatively charged particles. So the protons and electrons are same. So means positive charge is equal to negative charge. Okay. So atoms are neutral. But during the formation of compounds, means chemical bonds, what happens? Some atoms may lose electrons, some atoms may gain the electrons to attain the stability. Right, you know this one. Okay. When atom loses electrons, so it attains what? Positive charge. Right. And when atom gains electrons, then it attains what? Negative charge. Okay. Already we discussed the cation and anion. So what is that amount when for example one atom is losing one electron? What is the net amount of charge present on it? Plus 1. If it is losing 2 electrons, what is the net charge? Plus 2. So here also same. The net amount of charge present on any atom in a molecule. That is called as okay, oxidation number. So now, for example, I'll explain you. So example you see. For example, if I take hydrochloric acid, the formula is HCl. Actually, students, HCl is neutral. HCl is what? Neutral. This is a neutral compound. But if you see, okay, whatever the amount of present, means for example, if they split, okay, then what is the amount of charges present on it? 1. So here you see hydrogen has a positive charge, plus charge, and chlorine has a negative charge. Yes or no? Okay, in the hydrochloric acid, if they split, okay, then what happens? Hydrogen becomes positively charged and electron becomes negatively charged. Why? Because you know that chlorine atomic number is what? 17. Okay, so at the electronic configuration, what we write? 2, 8, 7. In the last cell, how many electrons are there? Only 7 electrons are there. So to attain the stability requires one more electron. So it takes one electron from the, like, okay, chlorine, right now. So here, like hydrogen is losing one electron, so it becomes positively charged, and chlorine is gaining one electron, it has a negative charge. So the net amount of charge present on the hydrogen in the HCl molecule is H plus. Means what? Plus means what? We are not writing any number, so therefore the plus one. And what is the net amount of charges present on the chlorine? So that is minus 1. So the oxidation number of hydrogen is plus 1 and chlorine is minus 1. Clear? That's all. Okay. Now, for example, let us take some other thing like, magnesium oxide. We take magnesium oxide. Now, what is the oxidation number of magnesium and oxygen? Okay. So, you know that magnesium oxide, if they split, it splits like Mg plus 2 and O minus 2. Yes? Yes or no? Why? Because you see a magnesium atomic number is 12. So 12 means what we can write it to 82. So here outermost shell should have the 8 electrons to attain the stability. So nearest gas is what? Neon. So it should have 10 electrons, but here 12 electrons are there. So what's happening to attain the stability? Magnesium is losing 2 electrons. Magnesium is losing 2 electrons. When it loses 2 electrons, it becomes what? Mg plus 2. Right? So now Mg plus 2. So meaning what is its charge now? Plus 2. Now here what happens? Oxygen. Oxygen atomic number is what? 8. So what we write the electronic configuration? 2, 6. Right? So here how many electrons are there? Only 6. To attain the stability, it requires 2 electrons. So it's taking this 2 electrons from the magnesium. So it takes 2 electrons. Then what happens? Oxygen, where it's taking 2 electrons, it becomes O minus 2. So here magnesium is losing 2 electrons, right? So that's what the oxidation number of magnesium is plus 2. Okay, plus 2. And here oxygen is gaining 2 electrons, right? So oxidation number of oxygen is minus 2 because it's gaining 2 electrons. Did you understand? Okay. So here according to our definition, again you see here, the number of electrons lost or gained by any atom during the chemical bonds is called as a atomic number. So here magnesium is losing 2 electrons okay, to form a bond with the oxygen, and oxygen is gaining 2 electrons okay, to form a bond with the magnesium. So magnesium is losing 2 electrons, so it becomes minus 2, and when it is losing 2 electrons, so it becomes plus 2, and oxygen is gaining 2 electrons, it becomes minus 2. So this plus 2 is the oxidation number of magnesium. This minus 2 is the oxidation number of oxygen. Did you understand? Very simple, no? So once you check, any doubt? Right. So like this we can check for the oxidation number of any compound, okay, any atom in a compound, right? But to find the oxidation number, to calculate the oxidation number, we need to remember some rules and regulations. There are some rules and regulations out there to find the oxidation number of any element. Okay. So now let us see that rule. Okay. So here rule number 1. Rules I am writing. Rule number 1. For any individual atom or individual molecule, the oxidation number of that atom or molecule is 0. The meaning is what? For example, if I take only carbon, there is only one carbon is there. Then what is its atomic number? What is its oxidation number? 0. Okay. So now for example, if I take copper, Cu, its oxidation number is 0 because it is individual. If I take silver, Ag, 0. If I take sometimes molecules like O2, okay, 0. Here 2 oxygens are there, but the oxidation number of oxygen is 0. N2, here also oxidation number of nitrogen is 0. Fluorine, F2, the oxidation number is 0. So students, here remember that the oxidation number of any individual atom, okay, or individual molecule like this, the oxidation number is 0. Okay. So, once if you see your material in the page number 68, the oxidation number of any atom in its elementary form is always 0. So, see here example, the oxidation number of hydrogen, oxygen, nitrogen, phosphorus are there in elementary form, means like in the form of elements are there. Similarly, hydrogen, H2, oxygen, O2, N2, P4, like this molecules are there. So, for these all are individual. Okay. So, now in such cases, the oxidation number of any elements is 0. So, for these elements, oxidation number is equal to 0. Remember this one. This is the most important point. Okay. Now, rule number 2. Rule number 2, the oxidation number of, okay, alkali metals. What are the alkali metals? Alkali metals means what? The first group elements except the hydrogen in the periodic table. Okay, lithium, sodium, potassium, rubidium, cesium, francium. Of course, francium is a radioactive element if you remove also. So, these elements are first group elements are called alkali metals. So, these alkali metals oxidation number is +1. Okay. So, here you can see this group. Can you see here? Except the hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Can you see here? So, this which elements are there? These first group elements except the hydrogen are called alkali metals. So, see here you can see a orange color, orange or alkali metals. So, the alkali metals oxidation number is 1 +1. Okay, remember that point, right? So, see here alkali metals. What are they? Lithium, sodium, potassium, rubidium, cesium. Their oxidation number is 1. Right? Now, similarly, third, the oxidation number of alkaline earth metals. The oxidation number of what? Alkaline earth metals. Alkaline earth metals. Alkaline earth metals are what? Second group elements. What are they? Beryllium, magnesium, calcium, strontium, barium and radium. Radium is a radioactive element. So, these elements oxidation number is equal to 2. Which elements? Alkaline metals. Where they are present? They are present in the second group of the periodic table. Where they are present? Second group. So, see here, beryllium, magnesium, calcium, strontium, barium, radium. These are the second group. So, second group elements are called alkaline earth metals. Can you see here? Alkaline earth metals. So, these are the alkaline earth metals. Okay. So, beryllium, magnesium, calcium, strontium, barium. So, first group elements except the hydrogen. Of course, hydrogen also exhibit +1. But in some cases, it also exhibits a -1 also. That I will explain you. Okay. So, the first group elements means lithium, sodium, potassium, alkali metals is +1 and alkaline earth metals is +2. So, first group elements +1, second group elements +2. Clear? Okay. So, that is the oxidation number of individual elements and alkali metals means first group elements and second group element that is that are alkaline earth metals. Okay. So, these are the 3 rules. You can, these rules are there in your material also. See students in the page number 68. Okay. Now, let us come to the rule number 4. General oxidation number of hydrogen is +1. Okay. So, if you see the fourth rule, rule number 4, the oxidation number generally of hydrogen is +1. Generally, it is a +1. Okay. For example, hydrogen, if it's combined with hydrochloric acid, I have given now. Okay. So, previous example I have given somewhere. See here, hydrogen +1 I have written. Okay. Oxidation number of hydrogen is +1. Even with the oxygen also it is like when the water, H2O, water formula is what? H2O. There also the oxidation number of hydrogen is +1. But when hydrogen react with the metals to form a metal hydrides, for example, sodium hydride, NaH. Okay. So, here sodium is there. This is what? Metal. Okay, sodium is what? Alkali metal. So here you see Na. It is what? It is what? A plus 1. Here I written 1 means what? Plus 1. So this is plus 1. Then if it is a plus 1, then this becomes minus 1 to make the overall charge is 0. The total molecular charge should be 0. So here sodium is plus 1, but here hydrogen exhibiting what? Minus 1. Hydrogen is exhibiting what? Minus 1. Means what? Hydrogen can exhibit the plus 1 oxidation state. Hydrogen can also exhibit minus 1 oxidation state. In which case? In metal hydrides. So oxidation number of hydrogen in metal hydrides, okay, metal hydrides is minus 1. Is what? Minus 1. Now we can see here, see that in general, okay, general oxidation number of fourth rule used in the page number 68, the general oxidation number of hydrogen is plus 1, okay, plus 1. But in metal hydrides or ionic hydrides, oxidation number is minus 1. So, see here these are the metal, alkali metals. When hydrogen is combining with the metals, then the hydrogen's oxidation becomes minus 2. When hydrogen is combining with the non-metals like HCl, here chlorine is non-metal. Next water, H2O, hydrogen is combining with the non-metal, oxygen. So it's combining with the non-metal, then hydrogen exhibit a plus 1 oxidation state. But when combined with metals, it exhibits a minus 1. So you have to remember, students. Okay. So this is very important point, right? Next, rule number 5. Rule number 5. Here the fluorine. Which element? Fluorine always exhibit minus 1 oxidation number in its compounds. Okay, always it exhibit what? Minus 1. Where is the fluorine? Here is the fluorine. See, this is a fluorine. Okay, fluorine is the most electronegative element in the periodic table. The most electronegative element is in the periodic table is fluorine. So that's what fluorine always exhibit minus 1 oxidation state. Okay. Whatever the element with it combines, fluorine combines, its oxidation number is minus 1. Its oxidation number is what? Minus 1. So, fluorine always exhibit the minus 1 oxidation state. So, you can see the fifth rule. The universal oxidation number of fluorine in all its compound, wherever, with what elements it combines, no issue. Okay, its oxidation number is minus 1. Clear? Okay, this is the rule 5. Now come to the rule 6. Rule 6. It is important. Generally, okay, generally means what? Mostly. Okay, generally the oxygen, okay, the oxidation number of oxygen is minus 2. Okay, is what? Minus 2. Oxidation number of oxygen is what? Minus 2. Here I have shown with the magnesium oxide now. See here, oxygen is minus 2. Oxygen is minus 2. So, generally, oxygen exhibit minus 2 oxidation state. Okay, minus 2 oxidation state generally. But in peroxides, where in peroxides, remember here, this word is very important. Peroxide. Peroxide means what? If the bond is between oxygen and oxygen. The bond is between oxygen and oxygen. In peroxides, the oxygen exhibit minus 1 oxidation state. What is the oxidation state? Minus 1 oxidation state. It exhibit what? Minus 1 oxidation state in peroxides. In peroxides, it exhibit a minus 1 oxidation state, and in sometimes superoxides. Okay, in superoxides, okay, this exhibit minus half also. Okay, they exhibit what? Minus half oxidation state. Okay, so very important this one. Okay, generally oxygen exhibit minus 2. Generally we have to take minus 2 only, but in peroxides you have to take minus 1, and in superoxides you take minus half. Okay, so once go through this one, this slide within 1 minute. So oxidation number of hydrogen is generally what? Plus 1. Okay, generally when it reacts with the non-metals. But when it reacts with the metals or metal hydrides, it shows up minus 1. Generally with the non-metals, it is plus 1. With the metal hydrides, it is minus 1. Fluorine always exhibit -1. Oxygen generally exhibit -2. In peroxides -1 and superoxides -. Right. So this is about this one. These are all the rules you have to remember. You have to remember all these rules to calculate the oxidation number of any element. Okay. Now, seventh rule. Seventh rule. Rule number 7, what it states? 7 only, yeah? Rule number 7. Rule number 7 is what it states. The maximum number, oxidation number exhibited by any element is equal to maximum oxidation state exhibited by its element is its group number. So, it's a group number. This is very important. So, here you can see, here Roman numbers are not given. Actually, if the Roman numbers are given, then, okay, let me check. Can I write anything here? No. Okay, so here, so this is a Roman number 1, this is 2, this is 1A, 2A, and this is 3A, and 4A, this is 5A, this is 6A, this is 7A, this is 0, okay, and this is called 3B, this is 4B, this is 5B, this is 6B, this is 7B, this all, okay, 3, 1, 2, 3 or 8th group or 8th B also we can say 8th group, and this is 1B, this is 2B. So, meaning is what? This group cannot exhibit the oxidation number greater than +1, greater than +1. It can exhibit +1 or less than +1, but not more than 1. Okay. So, see, a hydrogen can exhibit +1. Okay. It also can exhibit -1, which is less than 1. Okay, but not more than 1. So, here these elements cannot exhibit +2, +3 something. And these elements obviously they exhibit +2 because its group number is 2. Okay. This group, see, Roman number is what? 3. So, these elements can exhibit maximum of 3. They can exhibit 1 also. They may exhibit 2 also. They may exhibit 3 also, but not more than 3. So, here group number, this one exhibit only 4 like this. Okay. So, here you can see this can exhibit maximum oxidation number 7. This can exhibit 6. This can exhibit 5. So, these are their oxidation numbers. So, oxidation number should not cross. Okay. It's a group number, that is most important. So, from this what I come to the maximum oxidation number exhibited by is how much? 8. See here, 8 is the maximum number. Anywhere is there 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 0. So, 8 is a maximum number. So, in the periodic table 118 elements, out of 118 elements, the maximum oxidation number exhibited by any element is 8 only. Okay. So, maximum oxidation number exhibited by any element is 8 only, not more than that. Clear? Okay. So, this is clear now. So, this is the rule. So, once read the rule. 7th rule in the page number 68. The maximum oxidation number exhibited is equal to its group, that is Roman number. I written Roman number only there. Okay. In the long form of periodic table. And see here example you see. The maximum oxidation number exhibited by iodine group is +7 and osmium is +8. Okay. So, see here iodine, see here this is the iodine. And what is the group number? 7. So, it can exhibit 7. And the next what is given here? Osmium. Osmium, where is osmium? Here. Osmium belongs to where? 8. So, that exhibits the C I written 8. So, 8 is the maximum oxidation number exhibited by any element in this periodic table. Clear? So, that is the 7th rule. Once read the 7th rule in your material. Chalo, that's about the so maximum oxidation number of any element should not cross or should not exceed its group number. Okay, this you have to remember, right? Now, 8th rule, the oxidation number of an atom in its charged monoatomic ion is equal to the charge on the ion. Okay, for example, if I write Like what can I write? Ca plus 2. If I written like this. So here what is its oxidation number? So the oxidation number is here Ca plus 2. So therefore the oxidation number of calcium is equal to plus 2. So what is the charge is written? That only. Okay. For example, if I write N minus 3, then what is this one? The meaning is oxidation number of nitrogen. What I written at the top? Minus 3. So that is minus 3. Okay. If I write I minus 1, minus, okay, generally minus we don't write. Okay. So minus. So the meaning is what? Oxidation number of iodine is equal to minus 1. So here, okay, the oxidation number of any charged ion is equal to its charge, So here Ca plus 2, this is one cation. On its, what is the charge? Plus 2. So here the oxidation number of calcium is plus 2. Here I written nitrogen minus 3, nitride ion. Okay. So one nitride ion I written minus 3. So here oxidation number of nitrogen is minus 3. Here I written iodide ion, I minus. So here minus. So oxidation number of iodine is minus 1. Okay, like that. So see here eighth rule, the oxidation number of an atom in its charged monoatomic ion is equal to the charge on the ion. So see here chloride, oxidation number of chloride is in chlorine is minus 1, like that. Okay. So these are the examples, right? Then come to the next one. Rule number 10 I will take. The sum of the oxidation numbers of all the atoms in the molecule is equal to 0. This is very important. Okay. This is very, very important. The oxidation, sum of the oxidation numbers. Sum means what? Addition. Sum of the oxidation number of all the atoms in a molecule is equal to 0. The meaning is what? For example, if I have one molecule, what I should take? Sulfuric acid I will take. H2SO4. Okay. So, what is the sum of the oxidation? Sum means what? Addition. Okay. So, first I read sum of the oxidation numbers of all the atoms, okay, in a molecule, okay, okay, is 0. Okay, the meaning is what? For example, H2SO4 is there. So here the sum of this oxidation number, the total oxidation number of all these elements is 0. You have to remember this one. Okay. If I write sodium chloride, the total is equal to 0. Okay. If I write calcium carbonate CaCO3, here also that is 0. Any individual molecule if I take, okay, this molecule if I take, the sum of the oxidation numbers of all the elements in the molecule is 0. Okay, this is the most important point. So this point helps us in calculating the oxidation number. For example, here previously I told you that hydrogen oxidation number I discussed, oxygen oxidation number I discussed, but I didn't discuss about the sulfur oxidation number in the previous slides, right? So here you see hydrogen we have somewhere +1. Where is that? Chalo, hydrogen here I have discussed, here +1, right? And I also discussed about the oxygen. So oxygen generally minus to this also I discussed. But I did not discuss anywhere about the sulfur. Did I discuss the sulfur anywhere? No. So you don't know what is the oxidation number of sulfur. Okay. So how can you find the oxidation number of the sulfur here? So by using this rule. The sum of the oxidation numbers of all the atoms in a molecule is 0. Okay. So by using this rule, you can find the oxidation number of sulfur. How? I'll explain you. Now see, I want to find the oxidation number of sulfur in H2SO4. Right? So now what I do? Here see, how many hydrogens are there? 2 hydrogens are there. So I'll write it 2 into hydrogens. Correct? Now plus how many sulfurs are there? 1 sulfur. 1 into sulfur plus how many oxygens are there? 4 oxygens. 4 into oxygens. So is equal to 0. Okay. So according to which rule? This rule. The sum of the oxidation number of all the atoms in a molecule is 0. So that's what I am doing. This 0. Now I'll write here 2 into hydrogen. Oxidation number what I said generally plus 1. So I'll write plus 1 plus 1 into sulfur. I don't know the sulfur. I have to calculate the sulfur. Now what I written here? 4 into oxygen. Generally oxygen atomic number, oxidation number what I said 2. So I'll write 2 here is equal to 0. Correct? 2 into plus 1 is 2 plus sulfur. Here oxygen is minus 2. Sorry, oxygen is minus 2. So 4 into minus 2 minus 8 is equal to 0. 2 minus 8 is equal to minus 6. So S 2 minus 8, sorry, 2 minus 8 is equal to minus 6 is equal to 0. Now plus 6, minus 6 I am taking that side, it becomes a plus 6. So the meaning is what? The sulfur oxidation number is 6. Sulfur oxidation number is what? 6. Did you understand? Once you check. Okay. So once again, if you want me to explain, once again I'll explain you. Okay, once again I'll explain you. So I'll rub this all. See, once again I'll explain you. So see here, 2 hydrogens, 1 sulfur, 4 oxygens. Sum of all oxidation numbers is equal to 0. 2 into hydrogen. What is the oxidation number of hydrogen? I said you plus 1, right? And oxygen is what I said? Minus 2. Correct? You have to remember this all. So hydrogen is plus 1. So I am writing just 1. Plus 1 into sulfur is sulfur. Plus 4 into oxygen. Oxidation number is what? Minus 2 is equal to 0. Now 2 into 1, 2 plus S plus here 4 into minus 2. 4 into minus 2 minus 8. So minus 8 is equal to 0. So S, this S I'll write here. Plus 2 minus 8, that is minus 6 is equal to 0. And S is equal to plus 6. So the oxidation number of sulfur is minus 6. So like this, we can calculate the oxidation number of any element in a molecule. Is this clear? So this is a way of calculating the oxidation number. Once you check fast. Understood? Chalo. So with this, one more example also we can see. K2Cr2O7. Okay, they are given potassium dichromate K2Cr2O7. For example, this is there. And I want to find the chromium oxidation number. I don't know chromium oxidation number. So how can we find? Listen carefully here. This is one more example I am explaining you. Okay. So here K2Cr2O7. Here I would like to find the chromium oxidation number. Okay. So how can you find? Now see how many potassiums are there? 2 potassiums here, right? So I'll write it 2 into potassium first. Okay. Plus how many chromiums are there? 2 chromiums. So 2 into chromium, right? Now plus how many oxygens are there? O7. So 7 into oxygen, right? Understood now? Now here what is the oxidation number of potassium? Plus 1. Why plus 1? Because potassium is an alkali metal which belongs to the first group. See, alkali metal, potassium. Potassium belongs to the first group. Alkali metals, oxidation number is plus 1, right? So plus 1. So plus 1. Plus 2 into chromium. I don't know the chromium. I want to find the chromium only. So I write chromium as is chromium. Plus 7 into oxygen. You know that oxygen exhibit minus 2. Correct? Is equal to 0. Sum of all the oxidation numbers is 0. No? So I am writing 0. Clear? Then what we do? 2 into plus 1 is plus 2. Plus 2 into chromium is 2 chromiums, 2 Cr. Plus 7 into minus 2. Okay, minus 2 into 7 is minus 14. So this becomes what? Minus 14 is equal to 0. Correct? Now this 2 Cr I'll write like this only. Here 2 plus 2 minus 14. Plus 2 minus 14 is minus 12 is equal to 0. Now 2 into Cr. 2 Cr means what? 2 into Cr is equal to minus 12 is going that side, it becomes plus 12. Now I want Cr. So Cr is equal to this multiplication 2. If I bring here, it becomes denominator. So 12 by 2. 2 ones are 2 6 are. So Cr is equal to plus 6. So the oxidation number of chromium is equal to plus 6. So like this, I can calculate the oxidation number of any unknown element. Clear? So these are the rules to be learned. Very simple concept this oxidation number. Okay. So this is a third synopsis. Very simple. In your materials clearly it is mentioned. Okay. You have to find it. Is this clear? Chalo. Here some examples are given. Oxidation number exhibited by nitrogen. Okay, is given. In that how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 are there. Okay. And besides their formulas are given and their oxidation numbers also given. Right. But in that term, I'll explain only 3. Any 3 of which. 1 to 4, 1 I'll explain you. 5 to 8, 1 I'll explain you. 9 to 12 I'll explain you. So 1 to 4, which can I explain you? Nitrogen sexquick oxide, that is N2O3. Shall I explain about that one? N2O3. So here I would like to find the oxidation number of nitrogen in N2O3. Correct? So what is the oxidation number of nitrogen? So see, I don't know the nitrogen. I want to find it. So how many nitrogens are there? 2 nitrogens. 2 into nitrogens. Plus how many oxygens are there? 3 oxygens. 3 into oxygens. Okay. And the sum of oxidation numbers of all the elements is 0. Correct. Now 2 nitrogens, right here 2 nitrogens only. Okay. Plus 3 into oxygen. Oxygen is minus 2. You know that oxygen is minus 2 is equal to 0. 2 nitrogens plus into minus 3 2s are 6 is equal to 0. 2 nitrogens is equal to minus 6 is going that side. So plus 6. Nitrogen is equal to plus 6 by 2 is coming here. 2 ones are 2 3s are. So therefore nitrogen is equal to plus 3. Check there. Plus 3 is only now. Yeah. So see there in your material page number A69. That is plus 3. Understood? Now similarly, for example, let us take the sodamide we take. Sodamide. Okay. Sodamide. NaNH2 is a sodamide. Okay. NaNH2 is a sodamide. Okay. Sodamide. Okay. So what is its oxidation number of sodamide? NaNH2. Okay. So NaNH2 is a formula of sodamide. They are asking to find what is the oxidation number of nitrogen. Okay. So now what we can do? So see here, how many sodiums are there? 1 sodium. 1 into Na. Correct? Plus how many nitrogens? 1. 1 into nitrogen. Plus how many hydrogens are there? 2. 2 into hydrogens is equal to 0. 1 into sodium. Sodium is a plus 1. 1 into plus 1. Okay. And I don't know the nitrogen. How to calculate? So 1 into nitrogen. Plus 2 into hydrogen is plus 1. Yes or no? Is equal to 0. So 1 into 1 is 1 plus nitrogen plus 2 ones are 2 is equal to 0. 1 plus 2, 3. N plus 3 is equal to 0. N is equal to plus 3 is going there minus 3. That's all. So see there. Sodamide, which one? 1, 2, 3, 4, 5, 6, 7, 8. 8th one you can see there. Okay. Minus 3. Clear? So like this you need to calculate the oxidation number. Okay. So this is about the how to calculate the oxidation number. So in the page number 6 students here 69 about the nitrogen, the table you can see nitrogen can exhibit different oxidation numbers. Okay. So maximum oxidation number is what? Plus 5. See here plus 1 plus 2 plus 3 plus 4 plus 5 plus 3 plus like this. But maximum oxidation number how much is given? Say for nitrogen plus 5. So here you see in the periodic table nitrogen belongs to C plus 5. Correct? So nitrogen oxidation number should not exceed the plus 5. Okay. So that is the things to be remember. Right. Now similarly, if you turn the page number 80, there also oxidation number exhibited by carbon is given. Okay, one see. Can you try? Try 1 or 2. Will you try? Okay. For example, you take anything. Which ones will you take? carbon monoxide we take. First one, carbon monoxide. The page number 70, carbon monoxide. Carbon monoxide. So carbon monoxide formula is what? CO. Correct? So here now how many carbons are there? One carbon. 1 into carbon. Plus how many oxygens are there? One oxygen. 1 into oxygen. The sum of the oxidation numbers is what? 0. So carbon we don't know. So 1 into carbon, carbon only I'll write. Plus 1 into oxygen. Oxygen oxidation number is what? -2 is equal to 0. So carbon plus into minus minus. Okay, 1 2s are 2 is equal to 0. Now see -2 is going there, it becomes +2. So oxidation number of carbon is +2. So see that oxidation number of carbon is +2. Clear? So this is about the oxidation number. You try all these oxidation numbers, right? Will you try? Try. Now one more I'll explain, some typical one I'll explain you. I'll explain the sucrose. Sucrose is there one. Okay. Do you know what's the formula of sucrose? Okay. So sucrose, let us see the sucrose. Sucrose formula is what? C12H22O11. This is a formula. In this I want to find what is the oxidation number of carbon. So what can I do? See here now. How many carbons are there? 12 carbons. So 12 into carbons. Plus then what I write? H22. 22 hydrogens are there. 22 into hydrogens. Right? Plus how many oxygens are there? 11. So 11 into oxygens. So sum of the oxidation number of all the elements is what? 0. So write 0. Correct? So 12 into carbon. We don't know. So write carbon. We are finding carbon only. So we don't know the carbon. Plus 22 into hydrogen. 22 into hydrogen. You know that plus 1. So plus 1. Plus 11 into oxygen. Oxygen you know that -2 is equal to 0. Now 12 carbons. Plus 22 ones are 22. Now here. Plus into minus here, plus into minus minus, 11 twos are 22 is equal to 0. Now 12 carbons plus 22 minus 22 cancel. Okay, 12 plus 12 is equal to 12C is equal to 0. C is equal to 0 by 12. 0 by something is what? 0. So the oxidation number of carbon in sucrose C12H22O11 is 0. Can you see that in the table? Last but 3. Okay, understand how to calculate? So in this way, you can calculate the oxidation number of the elements. Clear? Chalo. And beside one more, the page number 71, there is one more table is also there, students. That is, now it's not required because they exhibit the different oxidation numbers. This in the higher classes you learn, now it's not required. So till here you practice oxidation number of carbon. Okay. So with this we completed the synopsis 3. Okay. And now we solve some concept based questions so that you can understand here. Okay. Now open the page number 72 and here you see concept based question. The number which indicate the loss or gain or share the electrons by atom during the formation of chemical bonds. What is that? See, the number of electrons lost or gained or shared by any atom during the chemical bonds. What is that? Oxidation number. So the first question option is 1. Next, the oxidation number of an atom in its elementary form 0. Elementary form means what? Individual. Okay, like this. Like this. Carbon 0, copper 0, silver 0, oxygen 0. So that is 0. So here also second one is also 1. The common oxidation state of alkaline earth metals. Alkaline earth metals is what? Plus 2. What it is? Plus 2 is equal to plus 2. So the option is what? 2 is the option. Fourth one. The oxidation number of oxygen in superoxide. See, in superoxide, the oxidation number of superoxide is minus of. So option is minus of. Fourth one is 2. Fifth one. The oxidation number of S in S8 molecule, that is individual molecule. Okay, individual molecule like this N2, O2, F2, similarly S8. So that is equal to 0 only. So the answer is 0. So fifth option is 1. In which of the following the chlorine exhibits the oxidation state +5? You have to calculate this one. Okay, you calculate all, you can check the answer. Okay, roughly if I calculate oxygen, for the first one, oxygen is -2, -2 4 is -8 plus 1, no, that becomes 7. Oxygen is -2, -3 is -6 plus 1. So the option is sixth one is chlorine, how much they are asking? +5. So option is 2. Okay, second option. Let's check. So what is that? HClO3, right? HClO3. You have to calculate. You find it. Okay. So hydrogen. How many hydrogens? 1. 1 into hydrogen. Plus how many chlorines? 1 chlorine. 1 into chlorine. Okay. Plus how many oxygens? 3 oxygens. 3 into oxygens. The total oxidation will be 0. 1 into hydrogen. Hydrogen is +1. Plus 1 into chlorine. We need to find the chlorine only. So chlorine. Plus 3 into oxygen is -2, okay, is equal to 0. So 1 into 1 is 1, plus chlorine, plus into minus, 3 2s are 6 is equal to 0, plus 1 minus 6, okay, plus 1 minus 6 is -5 is equal to 0. So chlorine is equal to +5, correct? So the option is HClO3 is the right answer. Take that one. Next. The oxidation number of carbon is 0 in glucose. Just I told you about the sucrose, I told you, but in the glucose also similar way only. So here I told you the sucrose, C12H22O11, even in the glucose also. Okay, glucose also C6H12O6. So here also the oxidation number is of carbon is 0. Okay, so the option is 7. The oxidation number, okay, of the oxygen in chromium is, sorry, chromium pentoxide. See students, a chromium pentoxide, here you can't write like this. See a chromium pentoxide, for example. Oh, pages are over. Okay, so see a chromium pentoxide. CrO5 is given. Okay, for this some exceptional cases are there. For CrO5 you can't write like this. Okay, 1 chromium, here 5 oxygens. 5 into -2 -10 is equal to 0. So C becomes Cr is equal to +10. So +10 is not possible. The maximum oxidation state of any element is 8 only. But here like this, if you calculate, you'll get +10. So this is the wrong. Okay. So for that you need to see the structure of this one. So once if you see the chromium pentoxide structure in the page number 71, you have the structure. So see a chromium, a double bond O. And the structure you see, structure is like this of chromium, sorry, oxygen, oxygen. Okay, so like this structure is there, right? So here in the structure, what we do is, okay, by seeing the structures you have to do. Okay, so here this is +2, right? This is +2. Here +1, here +1, here +1, here +1. Okay. So like this you have to take. Here oxygen and -1 means what? Chromium is a +1. Here +1, here +1, here +1, here +2. So total 2, 3, 4, 5, 6. So the option is okay, -6. Okay, or -6/5 we can give the option for that one. Clear? So this is, you can see in the page number 71. Page number 71, last one you can see. Okay. So by using the structures also you need to do, but this you will learn in the higher classes, no problem. Next, 9th one you see, if HNO3 changes to N2O, the oxidation of the nitrogen changes to. In HNO3, what is the oxidation number? It becomes 3 minus 6 plus 1 is equal to +5. +5 to it changes to +1. Okay. So +5 to changes to +1. Okay. So change in the oxidation number is 4. Okay, this you have to do. And oxidation numbers present in oxygen in KO3 and this one. Okay, so here you see. Okay, here I am doing, you see, which one first we do the 9th one. In HNO3. So see here hydrogen oxidation number is +1. I am writing directly. Nitrogen I don't know. So write N. Oxygen is -2, -2, 3 is -6. is equal to 0. So plus 1 minus 6 is equal to plus minus 5 is equal to 0. So nitrogen minus 5, if I take that side, it becomes plus 5. So in the nitric acid HM3, I am getting nitrogen oxidation number is plus 5. And next what is given? N2O. N2O is given. Here nitrogen oxidation number is also 2 nitrogens, so no 2 nitrogens, and your oxygen is minus 2. Minus 2 is equal to 0. So 2 nitrogens is equal to minus 2 is going that side, so it becomes plus 2. Nitrogen is equal to 2 nitrogens. 2 bring here 2 by 2, so that's equal to plus 1. Okay, so difference is how much? 5 minus 1, 5 minus 1 is 4. So answer is plus 4. Okay, so plus 5 to plus 1 it's coming. So how many changes? 4 is changed. So the answer is fourth option. Now 10th one also you see the oxidation number of oxygen present in KO3. Okay, KO3. KO3. They said oxidation number of oxygen they said. So here you know that potassium oxidation state is plus 1. What is the potassium oxidation state? Plus 1. So here plus 1 and oxygen we don't know, 3 oxygens are there, right? So then what you write? Plus 1, okay, plus 3 oxygens is equal to 0, and plus 1 is going there, it becomes minus 1. So 3 oxygen is equal to minus 1, oxygen is equal to minus 1 by 3. So minus 1 by 3 is equal to 0.33 something you'll get. So the option is the last option, okay, that is fourth option, minus 0.33. Okay, so these are the some of the questions are there, and try to solve these questions. Okay, so try to solve these questions and read. The concept is very important, students. Here only the concept is very important, only rules are there. So these rules you have to follow. Okay, if you follow the rules, if you can understand the rules, so you can find the oxidation number of any element in a compound. Okay, so with this we stop and practice this all oxidation numbers. So many are the rules are there, so follow the rules, and so many examples I have given here, number of examples I have given in this class. So these all examples you have to practice, some other examples also you have to practice to be perfect. Okay.